For Lab 5 Objective 1, the LED is being powered by the pulse width modulation pin 11 on the Arduino board. Then the current goes through a 220 ohm resistor and then back to ground on the board. The code for this is using the analog write function separated by a half-second delay to power the LED at 25, 50, 75, and 100% power. The goal for Objective 2 was to have the speed of the DC motor controlled by the potentiometer. So, the positive comes, let's see if I can get a better view of it, comes out of the 5 volts here, goes into the one side of the potentiometer, and then from the middle of the potentiometer, where it varies, it goes to the positive side of the motor. Then the negative side of the motor over here goes back to ground. So when the resistance is lowered enough, the motor will start back up. Theoretically, raising the resistance would slow down the motor, but even the slightest little bit of resistance slows down the motor enough where that it just stops altogether. So still acts as kind of like a switch though. For Objective 3, the goal was to get the potentiometer here to indirectly control the speed of the motor. So, and as you can see, as I turn the potentiometer, you can hear the motor slowing down, eventually comes to a stop. If I turn it the other way, it should start back up again, although sometimes it needs a little help. There we go. Alright, so the circuit starts with the potentiometer side. We have the 5 volts and ground coming off of the Arduino board to the strips over here, and the positive comes from the strip through the resistor and then back to ground here. Through the potentiometer. The middle pin for the potentiometer reads where it is and sends it to analog port A0 over here. And on the motor side of the circuit, we have the positive going to the motor, through the motor to the transistor here, which then on the far pin goes to ground, and on the middle pin goes to the PWM port 11 on the board, which will control the transistor. The code for Objective 3 starts up here by naming each of the pins being used. Then we enter setup, where it sets the motor pin to output, which controls the transistor, and starts the serial monitor and sets the speed at that. For the loop, it starts with a delay. Next, creates a variable here, which is equal to whatever it reads from the potentiometer. Next, it puts that number into the serial monitor, so we can see it here. Next, it creates the variable map, and that's equal to the map function, which basically takes the 0 to 1023 that it gets from the potentiometer and equates each of those values to 0 to 255, which the analog write function can then use to power the motor, or set the speed for the motor through the transistor. So as you can see, as I move the potentiometer, the numbers there change. So as the numbers go up, it pulses, it sets longer periods between pulses, thus lowering the overall voltage to the motor, or average voltage I should say, to the point where it slows down. For Objective 4, the goal is to have the motor turn on when the button is pressed and the potentiometer value is above 500. So right now, the potentiometer value is below 500, so when the button is pressed, nothing happens. When I turn the potentiometer up, above 500, as seen there. Now when the button's pressed, okay, it tries to turn on. There it goes. So, the circuit, the potentiometer is wired exactly the same as last objective. The button is wired on one side to positive, and the other side is wired through a 10 kilo ohm resistor to ground, as well as to pin 7 on the board here. The motor is wired directly to ground on this side, and pin 11 to be powered on this side. This is the code for Objective 4. It starts up here by naming all 3 pins. Here it sets the push button pin to input, the motor pin to output, and starts the serial monitor. For the loop, starts with the delay, names the value for the potentiometer, and sets that equal to whatever it is ever is read from the potentiometer. Displays that value in the serial monitor there. Next, it sets the variable push button state, sets that equal to whatever it reads from the push button. And the main part of the code is if the potential value is greater than 500 and push button state is high, which is connected, then it turns the motor on. It used a digital write statement for this as opposed to the analog write we were using earlier for simplicity's sake, since the speed of the motor doesn't matter. And anything else turns the motor off.